You're listening to China Manufacturing Decoded from the Sofeast Group. Today in episode 302, we are discussing how to reduce injection molding costs, but without sacrificing quality. Adrian here hosting. Paul Adams joins me today. Hi, Paul.
Hello, Adrian. How are you, sir?
Good, thank you. And I need some injection molding assistance, so I've come to the right place as normal.
Well, absolutely. You come knocking on the right door, let's say.
Great.
It's always good to be back talking about injection molding. You know me.
Yeah, and it's a recurring topic, but that's because we work on it with so many of our customers at Agilian. You know, they're having injection molded parts or enclosures for products and different elements like that. And one of the questions that you are asked relatively regularly is, how do we actually cut molding costs without hurting the part or product reliability, for example, or quality, right? And so the topic of today's podcast, we're not talking about cutting corners in a dangerous way, but we are going to look at why costs can balloon, but also some of the levers that we can pull to potentially reduce the cost, but while not actually hurting our product, which is the key point. So we're not just cutting costs with reckless abandon here, right? We're only doing it if it's safe and sensible to do so. I mentioned talking about why costs can balloon initially, and that's a good starting point here. And I suppose this is something that might spur customers to actually ask this question.
Well, true. And you're talking about sort of not cutting costs. The other way to put it is actually carrying out best practice designs or best practice. So, yeah, why do costs balloon? Well, there's a couple of obvious ones I want to touch on, Adrian. And this is really down to the the 2D or the technical drawing from a specification point of view on the tolerances. Okay, your toolmaker will follow instructions. All right, so they'll have the 3D CAD, and they will have the technical drawing, the details on the 2D drawing, which specify your tolerances. Now, if you go blindly in and saying I want 0.05 millimeters on absolutely everything, and you get a ridiculous tooling quote back, and you think, well, why is it so expensive? This is insane. Well, it's because it is insane, because of the tight tolerances are specified on areas that don't need to be. In other words, if you are looking at machining and then grinding and then hand polishing in order to get to that 0.05 millimeter tolerance, when it doesn't need to be, you've added so much time and effort, i.e. additional money, in order to achieve something that is not necessary. Okay, so that's the first part, overkill on tolerances. So the best practice there is only apply the tolerances on critical to quality attributes or sections of the part you're designing, i.e. the toolmaker will focus on those parts and have an open tolerances on areas that don't need to be held that tight. Okay, so that's the first thing. People do get carried away with, oh, I've got tight tolerances. Well, hey, look at us, we're heroes. Not necessarily the case. You're just adding unnecessary time and cost there. Another one that is overkill, which a lot of people, and I'm going to come onto this again a little bit later from a vanity point of view, is the cosmetic or the surface finish. Okay. Now, if you've got, for example, a consumer electronics part, inside the outer case, you've got a battery, and that battery is inside a cover, okay, in a separate compartment. If you're specifying you want a surface finish on that cover, on the lid for the battery case, why? No one's going to ever see it. No one's going to say, oh, look at the finish on this particular part that's inside the zone. Well, potentially you're only seen when you need to change the battery. Total waste of time. Total waste of time. So again, it's looking at being sensible with respect to specifying your surface finishes. Okay, so that's another thing we need to look at. So, which is really important. So, overtype tolerances, cosmetic overkill, and and something I'm going to come on to later on. We've been talking about. I'm going to do the MythBusters section later on, Adrian.
Mm,
Is cheap tooling wins? No, it doesn't. It costs you
yeah.
more than a standard tool, let's say, and I'll explain that later on. So that's that's basically, let's kick the ball off with respect to why the costs balloon to start with, because
Hmm.
people carried away with surface finish and tolerances. That's that's the biggest thing where you think, whoa, what's going on here? It's not paying attention or it's not following best practices.
Mm. Yeah, and that could just be because, let's say, in the case of a startup, maybe they just don't know.
Well, that's right. Exactly.
Yeah,
Or,
yeah,
yeah, if you're using a third party design house that's not paying attention and you don't know any better as a customer or a client, then you don't know any better.
yep.
And that's where you're going to get burnt, basically. So it's
Mm,
very important to work with reputable designers and tool makers all the way through.
yep. Okay, good. So I mentioned three levers that we could pull to potentially reduce costs. So let's start with the first lever, and that's design and DFM.
Yeah, yeah, it's really important. We'll go back to that sort of 3D CAD here, which is where the DFM takes place. Now, DFM, we're talking from a tooling point of view. I think I
Yeah.
mentioned this in a previous podcast that we talked about. There's various different stages where you could run a DFM. The DFM is designed for manufacture. So here we're looking at the tooling side of things. And again, your tool maker will look at the 3D parts and go, okay, we need this, this, and this changing. Your draft angles are not good enough, or whatever the case may be. Now,
Hmm.
again, we've got to follow best practices in order to get the savings. This is all this all it takes. Okay, looking about wall thicknesses. If you ignore the best practices from a wall thickness point of view, from a where your design actually goes around a corner and then you've got a rib and you haven't actually taken into consideration the sort of ratios of the rib, everything's uniform thickness, you're going to have problems. In other words, you're going to have sink marks. You're going to have a very poor surface finish on the A surface. In other words, the outside surface that matters because you haven't followed best practices. Also looking at the material. Again, we've mentioned material selection and choice on different podcasts, which you can go and have a listen to. But it's super
Mm,
important that you analyze the correct material for your part. Because if you say, you know what, just throw in ABS because I know that's a really good engineering polymer to go with. I don't really care because I've heard that ABS is really, really good. So the tool maker is going to make it to run ABS. ABS. Now, what he's going to do there is take into consideration the shrink rate of that particular polymer. If you then say, you know what, it's I really want to change it to some other polymer because I now want it see-through. I want a window that, so therefore you're going to go polycarbonate or acrylic or whatever. It's a totally different ballgame. It's a totally different shrink rate. In other words, your part's going to come out incorrect because the tool was designed for ABS. So again, it's really going back to basics and making sure that you're preparing your tool for what you need it to run. Okay. Now you can actually switch polymers as long as your shrink rates. Again, this is getting more technical than we need to, but it's all best practices with respect to matching what you need from the product in order to get the tool made to produce what you need. Best practices.
mm,
That's all it comes to, just logic. Another big one is draft angles. Okay. So draft angles are, do, throw your mind back to when you were a kid, where you're building sandcastles on the beach. You had one of these little castle buckets, and it was almost like a pyramid. Okay, you threw your wet sand in, you turned it upside, give it a bang with your spade on the top, and everything came out perfect. Why? Because it was a pyramid. In other words, the draft angles were so big that as soon as you come away half a millimeter or a millimeter, the bucket was no longer touching the sand and everything was free. Okay, that's what you call your draft angle. The smaller the draft angle, the more problematic getting the molded part out of the tool. Okay, so the greater the draft angle, the easier the tool runs. Therefore, it's more efficient. Therefore, your yield rate is going to be higher. Instead of having a really tight draft angle, it's going to be more problematic. Therefore, you're going to get more scrap rates. Or yeah, the tool molder is going to take into consideration the scrap rate and therefore increase the unit price. Okay, as well
Mm,
as the tooling price is going to go up because he knows he's going to have problematic issues with getting the part out of the tool itself. It's not going to run as smooth. So all of these things we need to be looking at and take into consideration the best practices in order to get that part out of a really well designed tool. Tolerances, again, I've already mentioned tolerances as the appetizer. This is a big thing. It really is a big thing. We need to make sure that we are looking at the tolerances are fit for purpose in the areas that need to. Okay, if you've got a hole that is a bolt hole, for example, is sort of fixing two parts together, there's no need to tolerance that to 0.05. I'm telling you, there's no need. Okay, your standard
mm,
tolerance. If you don't have a tolerance on your drawing whatsoever, your tool maker is going to be working to plus or minus zero point 0.2. It's going to be perfectly okay. No problems at all. No need to go crazy. Okay. Another one is gate geometry. Okay. When I'm talking about the gate, this is where the sort of the polymer is actually fed into the core and the cavity. It's this the actual point where it comes in. There are a number of different gate options and styles and sizes, and each of these will have an effect on the output of the molded part. So we need to make sure that we are optimizing our gate size and position. If your position's wrong, and I've seen this just last week in a product, just last week, where it was let's call it a washer. All right, I'm not going to give the part away. Call it a washer, okay? And we're injecting from one side. Obviously, there's in a washer's got a hole in the middle, and that hole is represented by a post in the tool, and the polymer has to hit that post and run around either side, and then form and come together around the other side of the post. You know what I'm saying?
mm,
And
mm,
that's where a weld line or a knit line, if things go wrong, okay, and it's frozen too quickly, you're going to have a line there. In other words, it's going to be a weak point in the part. Now, you
mm.
can actually eliminate that simply by the gate size and position. Okay, so again, it's looking at and talking to your tool maker to make sure that all of these critical areas are looked at from a best practice point of view, from an optimization point of view. So there's probably a few there that I've talked
Yeah.
about in the part design and DFM. Now, if we're smart, all of these things will be picked up in the DFM will be changed before we actually cut steel. Okay.
Mm,
Again, super, super important. As soon as you start cutting steel and then you want to make changes, price goes up. Okay.
yes.
You're making a change on the CAD, you haven't cut any steel yet. So it's all good. Yeah, we're in the good side.
Mm.
So
So, yeah.
that's probably lever number one, let's say.
Yeah, good. So, I mean, these are things that you need to take up with your designers who's working on your tooling design. Lever two, these would be tooling decisions. So, first we've covered design and DFM for tooling, right? But now more about the tooling itself.
Yeah, yeah. There's a couple of things that are obvious in my mind. One is the steel itself. Okay, so a lot of people refer to it as soft tools or soft steel, hard steel, steel. hard tools, it is somewhat irrelevant what you call it. It's the quality of the steel itself. Generally, is referred to as P20, which is more like the soft steel, okay, versus the H13. Let's say this is more like European or American standards we're talking about, if anything else. Which is H13 is the hardened steel. Okay,
Mm.
now, the difference here is the number of shots you can get out of the actual tool itself. Now, from a tooling decision point of view, does it mean that having the softer tool will be cheaper overall, or should you go with a hard tool? Well, it depends.
Mm.
It's on the life of the product, the life expectancy of the products, how mature your market is, how mature your business is, how mature your product is. If this is your first rodeo and it's like, oh, yeah, I've never sold anything before in my life, but I've just come up with this fantastic idea, let's go for it, then I would suggest that you go with the softer tool. You're still going to get 300,000 to 500,000 shots from that, which is a big
Mm.
number. It's still a big number. Why would I say that? Well, simply because if it's your first product out and you're actually getting your business off the ground, and you do get the business off the ground, and you start to actually get momentum, you will need version 2. You will automatically go for that upgraded product or
Yeah.
extended sort of product range within your sort of portfolio. So there's
Mm.
no need to run a fully hardened steel tool that's going to do 1 million plus shots. However, the cost difference between a soft tool and a hard tool is not as much as, two soft tools. Yeah. So,
Mm.
it's, I call it just for round numbers, a P20 steel tool is going to set you back, call it $20,000.
Mhm.
An H13, maybe $35,000. Okay. So it's not
Mm.
double, but you're going to get double or more the number of shots. So you really need to be smart with respect to the decision you look at from the tooling steel grade that you need. Okay. That's
Mm.
the first thing. Okay.
But if it fulfills your needs, a P20 mold, you're saving $15,000 roughly, and you're still getting the products that you need.
Exactly. And that
Mm.
$15,000 is marketing money, for example,
Yep.
or
Yep. Yep.
website money, or whatever the case may be. So it's smart decisions make the smart business opportunity, really. Um,
Mm.
Another one is a number of cavities. Okay, so you're gonna the more cavities, the more work. Now we talked about this before. You got the outside block of steel. Oh, we're talking about a block of steel. Yeah, one would assume that most people listening here understand what a steel sort of mold tool looks like. If you don't, this thing is like a big lump of steel.
Mm.
It weighs a lot. It weighs a lot. So, it's half. I'm sitting at a dining room table. It's probably half the size of this dining room table. Some of the big tools that we've got around our workshop. But it's the core and the cavity where the money is, which is where the part shape is. All right. So if you go for, I am the guy that's the startup, and I'm not too sure how things are going to go, but I'm assuming that my business is going to go through the roof. Do I go with a 32 cavity tool, or should I go with a 1 cavity tool, or maybe a 4 cavity tool? Well, I certainly would not go for a 32 cavity tool because that's going to cost you a lot more. Okay. Now your part cost will come right down. Okay. Now, again, this is where the numbers come into play. If you are a mature business and you've got a product that is selling and selling and selling and selling like hotcakes, yes, you want to invest in a larger tool that's got multiple cavities, simply because on every single time that tool opens and closes, you're going to get 24, 32, 36, components from that single open and close, or the shot, what we call. Okay, so that's where it makes sense. And your part cost is going to come right down. Okay, whereas
Mm.
this is a single cavity. which is your startup guy, the single cavity, two cavity, which is sort of fairly general. And again, this all about smart decisions, not spending in the money where you don't need to. Okay.
Mm,
This is not about bragging rights. This is about smart decisions, and taking control of your own costs when it comes to looking at your injection mold tools.
mm.
I want one more in there, Adrian, if I can,
Yep.
which
Yep.
is all about the hot runner and the cold runner. Now, again, so hot runner makes sense now because you're not wasting any material between the shots themselves. You've got none.
Mm,
Very good, very minimal sprue waste when it comes to sort of the injection process itself versus the cold runner. Now, again, this is all about being smart from a business point of view. If you are running a single product, same color, same process, same as everything. Yeah, invest in the hot runner. The hot runner is going to cost you a little bit more, but it's going to save you on material. In other words, your part cost doesn't come down, but your tooling price will come up a little bit. But it's going to be so much more efficient. And again, depends on the quantity that you require within your business. If you are running a part that's the same geometry, same shape, but you're running different colors, and we do have quite a few of those products running in our place at the moment, same product, but produced in 6 or 7, or I think we're up to 12 different colors now. Each time that
mhm.
color is run, yeah, you need to purge out the machine. That takes a long time. Your cold run all of a sudden makes sense because you're not wasting all of the sort of the material from the changeover point of view. But again, this is where you really need to talk to your mold maker and tool maker with respect to the numbers that you're looking at, the number of cavities you're running, the number of colors you're sort of optimizing for. So again, looking at that best practice from a strategic point of view on this point.
Mm. And if you don't know these ideas that you're sharing, then you're not really able to make those decisions that could cut costs where appropriate. So definitely these are good levers to make people aware of. Shall we move on to the third and final lever?
Yes, let's go. This is all
So
about
that's
processing and production.
yeah.
Okay. So it's I talked about sitting at my dining room table. And it's at the half of the dining room table is about it's a big tool. It's a big tool, but obviously there are a lot of smaller tools. Now, if you've got a tool that is capable of being run on a 90-ton machine, and that's the optimum size machine, you wouldn't necessarily want to run that on your 210-ton machine. You could quite easily. That's not a problem. But the efficiency, the amount of energy that machine is using, you're paying for additional energy to run the bigger machine where you don't need to. Okay, so
Mm,
these little tips and tricks you need to make sure that your mold maker is not actually, well, this batch, the price of your parts went up. No, that's not really looking at reducing the cost of the tooling, but this is just a free tip, let's say, as you're going on there. And it's really all about matching up the size of the tool to the tonnage of the machine. Okay, as opposed to, well, we've only got a 400-ton machine available to run your 10-ton optimized machine tool.
mm,
Um, it can be done, but it's not ideal. It's not ideal.
mm.
Okay. Another one is all about regrinds. We've all talked about regrinds. Regrind is take your cold runner system where you've got your part. Your part is attached to your sprue in your runner. The sprue in the runner is clipped off and wasted. Okay. Well, it's not
Yeah.
generally thrown away. What we do is regrind that and potentially use that on non-critical components, i.e., go back to our battery cover. That'd be perfectly okay. But there's a balance with respect to the amount of regrinds that you can use. If you use too much regrinds, it's gonna potentially damage your product itself, not necessarily the tooling, but your product will be affected from a mechanical structural point of view. So if you're
Mm.
trying to cut corners and cut cost on your part by using more regrind, be careful. This may be a very expensive mistake because you could get recalls because your part is no longer strong enough to meet the requirements. Okay, so that's one thing there. Processing materials. I like closed loop systems. I like SPCs on critical to quality. Control charts. Make sure the machine is running totally optimized. Make sure you got sensors all over the tool in order to allow the molder to make sure that you're running at an optimum level. Okay. This way is very, very efficient. You're going to get a high yield from your part. So all of the costs are going to balance out from a part point of view. Your yield rate is going to go up. So this is another process improvement for running your injection mold tools. Okay, so which I really like this one. I really like this one. And we're talking about
Mm.
pressures, temperature sensors, and everything like this. Loads of sensors that can be added in, cooling temperatures and optimization. So which is really good. Another one I just want to pick up here, if I can, just quickly. I know we're sort of getting to the end of this now, but it's all about optimizing the gate and the fixture automation. If, for example, and we do this on a few of our tools, in tool degating. Okay, now this could cost you, let's call it an extra 5,000 US dollars to add that technology into a tool. Okay, you think, wow, my goodness, that's an awful lot of money for in tool degating. Now,
Mm.
is it really? Because you're going to save so much money over the period of the tool life from a part cost point of view. It's going to pay for itself within 6 months, okay, or even less. So again, it's looking at new technology or technology that are not necessarily readily available for all other mold makers, and this is something that we do offer. So it's good.
You mentioned you were going to go through some myth busting as well, right? So I think that's a good quick fire section to basically finish on. So this is not only myths but also false economies.
It is, and I sort of like touched on a couple of these as we've been talking. Cheap tool is the best way. Wrong. That's definitely wrong. So we've definitely busted that one. Basically, what we're doing here is creating a cheap tool. If you've got a cheap tool, really cheap steel, and I'm not talking about the P20, I'm talking about some knockoff steel from around the corner. Just not budget. I just need a steel tool. Well,
Mm.
it's definitely the wrong way to go because you're not going to get any decent parts from that tool whatsoever. You may do for the first 1,000, but after that, it's just not going to work. And your mold sort of shop's just going to charge more and more and more and rework, and ultimately you're just going to have to pay for a new tool anyway. Uh, Cheap tools are definitely not the best way to forward. Now, yeah,
Yeah.
if you want a bridge tool, that's a totally different ball game, and I think we could talk probably for a whole 30 minutes on just bridge tooling. Which let's do that next time, Adrian. Um,
Okay.
but mirror finish, obviously, that has to be the best way forward, correct? Well, I've already told you about unnecessary surface finishes. Now, if you want a mirror finish, we can provide you a mirror finish. This is not a problem. However, the amount of labor that goes into producing a mirror finish and the slightest imperfection or slight bit of dust, slight imperfection in that surface will show up like a sore thumb. It's definitely not the way to go forward unless you really, really must have it. Okay? So
Mm.
avoid mirror finishes if possible. Okay. Uh,
Mm.
what's another one? Sort of family molds always saves. Well, it's if you've got totally. What I'm talking about a family mold. throw your mind back. This is where a family mold did work, is your Airfix models. Okay. As a kid, I used to build cars, planes, ships. My dad used to bring me a model home. It's like once a month. Yeah, go.
Yeah, yeah.
Exactly. But this is what you call a family mold, because you've got so many different
Mhm.
parts in one mold shot itself. It worked because all of the components are really, really small. Now, if you've got a total imbalance, so you've got one larger part and then you've got a number of different small parts in there, it can be a little bit tricky in order to balance the sort of the yield all of the time. Okay,
Mm.
so you got one part that's working really good. You got a couple of the smaller parts not working. So you got an imbalance with respect to when you are actually molding. How do you overcome that? Well, you got to mold more and throw stuff away. And so it really doesn't work. So sometimes you do need to invest in single tools for single components, or similar size if you're doing a family mold, in order to make it more cost effective. Okay.
Mm.
So that's
Mm.
basically, and the other one is hot runner, cold runner. Well, I just touched on that, so I won't repeat myself.
Yeah.
Uh,
Okay.
just a few myths, myth busters. I just wanted to quickly sort of tease you with.
No, no, those are good. So if we recap, right? So costs ballooning, maybe because best practices haven't been followed.
Yep.
The three levers, tooling design, DFM, then also the tooling decisions, such as the type of steel that you might use, and then the process, materials, and production setup. Would you say that the biggest savings likely to be gained are in the actual design phase then?
I think you hit the nail on the head there, Adrian. For sure. If you've got a really good design from a part point of view, if you've taken the time to do the tolerancing correctly, if you've taken the time to actually analyze where you want your surface finish, and then your tool maker and tooling guy will look at and do the DFM and highlight any issues that need to be optimized, that's where you're going to get the big wins. Okay, so if you can
Mm.
optimize before you actually start cutting steel, and then choose the correct option tool for the output your business requires. Okay,
Mm.
do those two things,
Great.
and you should be off to the races.
Excellent. Thanks for that, Paul. Informative and hopefully answering the question that some of our customers are definitely asking. So, how do we reduce injection molding costs, but do it sensibly? If you're listening and you have questions about this, well, do get in touch. You could even speak to Paul, and we'll be happy to help. And Paul has mentioned some earlier podcast episodes where we talked about, for example, polymer options. I will link to those in the show notes. Paul, always a pleasure.
Pleasure, sir. Looking forward to the next one.
Excellent. And back next week as normal. Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.